Hello and welcome to this CupOfT screencast. Today I want to talk about C++ const and thread safety. I think this topic is getting more and more important because more and more people are writing modern C++ multi-threaded code, and I think people are confused in general about what const means. Does it give you the thread safety guarantees or not? And if you go look on Stack Overflow, you can find answers like, well, it is somewhat true that const means thread safe in C++11, but it's a long answer with a lot of discussion, and usually they link to Herb Satter's talk on channel 9 about const and mutable and thread safety, where basically Herb claims that const means thread safe in C++11 because of some clause in how standard library is defined and so on. But I think people are now even more confused about const, because before people were confused about logical const versus bitwise const and what should it mean, and now there's an extra dimension to that with whether it's thread safe or not. I'm not sure if Herb was talking about future C++ or some subset of C++ or some static analysis tools maybe that they're working on, but it's relatively easy to see that there are many ways in which the compilers, the currently existing compilers, cannot guarantee thread safety with const. There are ways to just work around const. There's mutable. There could be mutable unsynchronized fields. This is all legal. You can legally cast constness away, though you should not. And there is also this very subtle way to have a data race with having a non-transitive const on the pointers. So if you have, let's say, class with a pointer field, then even if you have a const method on this class, when you dereference your pointer field, you're getting a mutable reference. You're getting a reference to non-const object, and you can do anything with it. You can increment it, and regardless of the fact that this is a const method and the unique pointer means ownership of this object. This is just the semantics of pointer dereferencing, and well, it's easy to see that even if you have a const instance of this class, or if you have a const reference to it, you can give it to two threads, and they will call this const method, and they will have a data race because they will both be writing simultaneously to that, incrementing the same point, the same counter. So what can we do about this? There is a proposal for C++17 actually about propagate const, so-called standard library class. And the proposal is basically that you will use it like this. You will just wrap your, let's say, pointer field in your class. And when you do that, then const method will work as expected here. So const method will give you const reference to when you go through that pointer. So there's an example on CVP reference. I'll give you the link. But still, like with other ways to avoid or break constness, this way requires some extra manual steps. So you have to add this propagate const method. You have to sort of have this best practice or discipline or some extra check. The compiler will not insist on that, at least not the current compilers. So then if compilers do not guarantee that thread safe with const, how can we write thread safe classes in C++? How can we ensure that there is no data race? There is only one way, at least I don't know of any static analysis tool or a compiler that would do that for you. Maybe there are some runtime tools like thread sanitizers or other tools which can help you find data races, but nothing in this from the static analysis world. So the only way really is to do the code review, and you can't just look at the header. You can just look at the header file and say, oh, this class is thread safe because there's const. You have to look at the implementation, review the implementation, and there are several practices that you can follow to write a thread safe class. You should still, use const methods and reference to const whenever you can. Even though they do not guarantee thread safety, they will still help you to avoid accidental change in the field when you don't want to. Also, don't cast constness away. It's just almost never needed. You will just sort of break the type system this way, and it's trying to protect you. I won't go into more details, but I'll refer you to ISO CVP core guidelines repository, and you can find there's a section on constants and immutability with more detailed advices about when to use const and how to use const. Use propagate const for pointer fields. If you can, if you have this experimental implementation, or if you can just add propagate const for your code base, it would be good. But this will protect you from this bug with getting a data race on a shared on something shared through a pointer field. If you can't have propagate const, then you need to review carefully all operations on the pointer fields. But really, it's better to have propagate const, because then compiler can do that check for you. Be extra careful with mutable fields, obviously, because that's one way to not have this const safety net. You will need some mutable fields, so probably if you use std mutex or std atomic, they will have to be mutable fields, and possibly something that's protected by a mutex. If you need to change it from a const method, something like maybe a cache on your class or a counter, you will need to also have it mutable, and you will need to review all usages of that field in the class to make sure they're always under the lock or a mutex. And finally, be extra careful with calls to non-member functions, static functions. Make sure they're thread safe. Maybe have a whitelist of like thread safe logging, caching counters, whatever you need to use. Obviously, this all assumes that there are no your class doesn't share data with other classes. If you share data with other classes, and it's mutable, you obviously need to make sure that there is synchronization on all of those members, and it's always used right. So this is for the writing the thread safe classes. So the last question here is, what about the non-const methods? So if we're saying that we need constness for thread safety, does it mean that when I see a non-const method, it is not thread safe and I cannot call it from multiple threads? The answer is yes. Non-const methods and non-const references can also be thread safe in some cases. For example, on internally synchronized classes, so-called, all methods are thread safe. So, for example, there could be classes like atomic or mutex. They are designed to be shared by multiple threads, and they're designed to be shared as mutable. So it means internally synchronized means that the reference to a non-const instance can be shared without creating a data race. I don't know of any standard way to distinguish such classes, so there you just need to know them. I know you need to know that a specific class is internally synchronized. So let's say if you look at std_mutex lock function, it is not const, so you will need to have mutable shared the mutex to use it from multiple threads, but that's okay because it is designed to be used from multiple threads. And similarly, if you have atomic and if you look at atomic store, it is also a non-const function, but it's okay. Multiple threads can share reference to the same atomic, and then they can simultaneously store something or load from an atomic, and this does not create a data race. So yeah, there's no way, they're not, there's no attribute on those classes saying that they are internally synchronized, and you may need to create your own internally synchronized classes if you're writing some low-level synchronization primitives. Maybe you're wrapping some events. There is no way to mark them as internally synchronized. You just have to state that in the documentation maybe. But yeah, then the reference to non-const class can be shared. On other classes, non-internally synchronized, you have to prevent data race by limiting writer access. So you would have to ensure that at any moment in time there is only one writer or multiple readers and no writers, so that you don't create a data race. But usually you will share reference to a const instance with multiple threads, and you will make sure that the const methods are all either synchronized internally or only reading, not changing anything. So I hope that CupOfT was useful for you and you enjoyed it. Bye.